Hello everyone, and in this lecture we are going to talk about DC power supply. So a power supply has one input and one output. And once we supply the input with AC power, we are going to get an output with a DC power. So most of the industrial control equipment, from digital sensor, actuators, will operate either on 12 volt DC or 24 volt DC. So it's standardized to these two voltage ratings. Now this doesn't mean that the control systems cannot operate on AC voltages. There is some control systems like a PLC, an HMI that operates directly on 110 volts or 220 volts AC. However, for protection purposes, it's recommended that all of these devices are combined in one circuitry that is operating on a certain DC voltage. Now the question is here, how do we choose a DC power supply? Every power supply has an output rating, which determine what is the maximum current that this power supply can deliver to your equipment. In our example here, we have a power supply with an output of 24 volt DC and 5 amperes as a maximum current that it can be delivered. So to know the exact current rating, we add up all of our DC devices' current ratings and we multiply that by 1.25, which means we add a margin of 25% to that current rating, and we choose our power supply accordingly. Now, why do we care about the current rating of our devices? Every device needs a certain power in order to operate. If we deliver less power that it needs, then that device will malfunction and it won't operate properly. Now, since we are providing a fixed DC voltage from our power supply, the only variable left to determine the total power is how much current we are providing. If we deliver less current, the device will be underpowered and it won't operate. That's why the power supply should be able to deliver enough power for that device. And since any device will consume more current in the first few milliseconds or few hundred milliseconds of its operation, we need to put a margin that this power supply can handle without the device failing at startup. And usually the nominal value that we choose is an additional 25% of the total current that we need. Now here's an important note. You can choose a power supply with higher current rating that you need. It's not okay to choose a higher voltage rating than you need, but it's okay for the current because the device that you are connecting this power supply into is going to take only the current it needs to operate, and it will not consume higher current values. However, choosing a higher voltage rating will probably damage your device. So voltages should be matched to the exact rating, and the current could be equal or more than the device rated current, because in current term, the device will only take what's necessary for it to operate.